Hey there everyone! Welcome to Math Tutor Hub, where math finally makes sense. I am Aaron Justin Beltran, your teacher for today, but you can call me Sir AJ for short. Now, let's tackle about the crucial concept of statistics, which is the measures of variability. So grab a notebook and let's learn together. Measures of variability, also known as measures of spread or dispersion, tells us that how scattered or clustered our data points are. A small measure of variability means the data points are close to the center, while a large measure means they are far apart. So, the simplest measure of variability to calculate is the range. So the range is the difference between the highest and lowest value in a dataset. So our formula for the range is equal to x, which is the maximum, minus x minimum. So for example, let's imagine we have the test scores of two different students. So student A have a test scores with 95, 92, 98, 93, and 94. And the student B have a test score 70, 85, 95, 100, and 100. Okay, so let's calculate the range for each student. So the highest score for student A, the highest score is 98. Okay, and the lowest is 92. Okay, very good. So the range is 98 minus 92. Okay, this is for student A. 98 minus 92. That is equal to 6. Now for student B, the highest score is 100. And the lowest score is 70. Okay, very good. Now the range is 100 minus 70 is equal to 30. So what does this tells us? So student A's score are more consistent, clustered together with small range of 6. So while student B's score are all over the place from a low to a perfect 100 with a much larger range of 30. Okay, so now the range is easy, but it only uses two data points. To get a more complete picture, we need variance. Okay, so variance is the average of the squared differences from the mean. It tells us how spread out the data is, but its unit are squared, which can be a bit tricky to interpret. So for our formula for our variance is s squared equal to summation of each individual point minus the mean raised to 2 over n minus 1. So this x1 is each individual data point, and this one is the sample mean, and n is the number of data points. So now let's use a new data set. So the daily high temperatures in degrees Celsius for a week in Santiago City, let's say our temperatures are 20, 22, 19, 25, and 24. So we find the mean. So we need to add the data. So 20 plus 22 plus 19 plus 25 plus 24 is equal to 110. Okay, very good. Divided by the number of values, which is 5. There are 5. Okay, so 110 divided by the number of values is 5 is equal to 22. So the mean temperature is 22 degrees Celsius. Now, find the difference of each value from the mean and square it. So the values are 20, 22, 19, 25, and 24. Now we will subtract it by the mean temperature. So 22 minus 22 minus 22 minus 22 minus 22, and now we're going to square it. So 2 squared, 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 and squared. So now let's compute. 20 minus 22 is negative 2 squared. 22 minus 22 is 0 squared. Now 19 minus 22 is negative 3 squared. 25 minus 22 is 3 squared, and 24 minus 22 is 2 squared. Now we're gonna square it. So negative 2 squared is 4, negative 0 squared is 0, negative 3 squared is 9, and 3 squared is 9, and 4 squared is 2 squared is 4. Okay, very good. Now we will sum the squared differences. So 4 plus 0 plus 9 plus 9 plus 4 is equal to 26. Okay, very good. This is the sum of squares. So now we will divide by n minus 1. Since we have 5 data points, n minus 1 is 5 minus 1. So it is equal to 4. So our s squared minus the sum of squares, 26 over the n minus 1, which is 4. So 26 over 4 is equal to 6.5. If you have a calculator, you may use it. Okay, so the variance is 6.5 square degrees Celsius. So see what I mean about the units? Square degrees Celsius isn't very intuitive. That's where our dex measure comes in. Okay. Now, the most commonly used measure of variability is standard deviation. It's directly related to variance and brings the value back to the original units of our data. So our definition for standard deviation is the square root of the variance. It represents the typical or average distance the data points are from the mean. So for our formula, where our standard deviation S equals the square root of S squared, okay, or the variance, okay, or S is equal to the square root of the formula for the variance, okay, over n minus 1. Okay, so now let's have another example. So now we finish our temperature problem. So we've already done all the hard work. We found that the variance for our temperature data was 6.5. Now we just need to take the square root of that number to find the standard deviation. Okay, so S equals to square root of 6.5 is approximately 2.55. So our standard deviation is approximately 2.55 degrees Celsius. This means that on average, a day's temperature deviates from the mean temperature of 22 degrees Celsius by about 2.55 degrees Celsius. So this is incredibly useful for our normal distribution. About 68% of your data will fall within one standard deviation of the mean, and about 95% will fall within two standard deviations. This single number gives us a powerful way to understand the spread and consistency of our data. So, to recap, range is the quick and dirty measure, just the difference between the max and mean values, while the variance is the average. So to recap, range is the quick and dirty measure, just the difference between the max and mean values, and variance is the average square distance from the mean, and standard deviation is the most common and interpretable measure, telling us the average distance from the mean in the original units. So understanding this measure is key to analyzing and interpreting any data set. So if you found this video helpful, don't forget to like, share, and subscribe, and hit the notification bell so you don't miss our next video. That's all. Goodbye!